Dear students, I am Dr. TAMRAKAR from Bharati College of Engineering and Technology. I am teaching fluid machinery in BE 5th semester. Today we will take one numerical. A single stage centrifugal pump with impeller diameter of 30 cm rotates at 2000 rpm and lifts 3 meter cube of water per second to a height of 30 meter with an efficiency of 75%. Find the number of stages and diameter of each impeller of a similar multi-stage pump to lift 5 meter cube of water per second to a height of 200 meters when rotating at 1500 rpm. Here the data given for single stage pump, and second is multi-stage similar pump. Multi-stage similar pump. Here these are the data given on these headings. Dia of impeller B1 is given 30 cm equal to 0.3 meter. Speed N1 is given 2000 rpm. Discharge Q is given 3 meter cube per second. Height HM1 is given 30 meter. Efficiency eta manometric is given 75% equal to 0.75, and for the single multi-stage pump, discharge Q is given 5 meter cube per second. Total height is given 200 meter. Let the height per stage is HM2. Height per stage. Let HM2 is the height per stage. N2 is the RPM, 1500 RPM. N2 is given. Diameter of impeller D2, we have to find D2. Now specific speed should be same. Specific speed of both are same. So N root Q by HM to the power 3/4 of 1 equal to N root Q by HM to the power 3/4 of 2. Now putting the values here, or we can change this formula as or we can write this as N1 root Q1 for clarity, HM1 to the power 3 by 4 equal to N2 root Q2 by HM2 to the power 3 by 4. Now putting the values here, N1 is 2000, root Q is 3, meter cube per second, and HM1 is 30 to the power 3 by 4 equal to 1500 root 5 by HM2 to the power 3 by 4. From here the value of HM2 is equal to 12.411 HM2 to the power 3 by 4 is 12.411. So the value of HM2 comes 28.71 meter. 28.71 meter, and number of stages equal to total head by head per stage. Number of stages equal to total head by head per stage. Head per stage. That is, total head is given 200 meter and head per stage is calculated 28.71. So this comes 6.96 or that is 7. So this is 7 stage pump. And now next, root HM1 by D1 N1 equal to root HM2 by D2 N2 for finding out the diameter of impeller. Diameter of impeller. HM1 is, now this is 30 by 0.3 into 2000, putting the values here. This is 28.71 square root, this is also square root, by D2 into 1500. So the value of D2 is calculated as 0.3913 meter. 3913 meter, or that is 391.3 mm. 391.3 mm. So we have to solve more numericals on this topic. We will take some more. Next question. Find the number of pumps required to take water from a deep well under a total head of 89 meter. All the pumps are identical and are running at 800 rpm. The specific speed of each pump is given as 25, while the rated capacity of each pump is 0.16 meter cube per second. Here the data given are total head H equal to 89 meter, speed N equal to 800 rpm, the specific speed Ns equal to 25, capacity Q is given 0.16 meter cube per second. Let HM is head developed by each pump. Let head developed by each pump. Now Ns equal to N root Q by HM to the power 3 by 4. Ns is given 25 equal to N is 800, Q is 0.16 and HM we have to calculate. So HM equal to, here this is 29.94 meter. 29.94 meter. Now number of pump required equal to number of pump required equal to total head by 8 developed by 1. Total head by head developed by 1 pump. By 1 pump. So total head is 89 meter and head developed by 1 pump is 29.94. So the value comes 3. This is around 3. So number of pump required is 3. Next question. A 1/5 scale model of pump was tested in a laboratory at 1000 rpm. The head development and the power input at the best efficiency point were found to be 8 meter and 30 kilowatt respectively. If the prototype pump has to work against a head of 25 meter, determine its working speed, the power required to drive it, and the ratio of flow rate handled by the two pumps. Here the data given are 1/5 scale model means that ratio of linear dimension of model and its prototype is equal to 1/5. Linear dimension of a model and prototype. This ratio is 1/5. Speed of model Nm equal to 1000 rpm. Head of model equal to 8 meter. Power of model 30 kilowatt. Head of prototype 25 meter. NP is speed of prototype. NP is speed of prototype, and PP is power of prototype. PP is power of prototype. QP is flow rate of prototype. Flow rate. And QM is flow rate of model. Now, speed of prototype. Speed of prototype. For this equation, root h by dm dn, h by dn of model equal to root h by dn of prototype, or this can be written as root hm by dm nm equal to root hp dp np. So putting the values here, hm is 8 by dm and so here np equal to root hp by root hm into dm by dp into nm. Putting the values here, this is root 25 by root 8 into 1 by 5th, as the data is given, 1 by 5th, and this is 1000. So NP prototype is 353.5 rpm. This is the NP. Now power developed by prototype. Power developed by prototype. Power developed by prototype. Here this power by d to the power 5 and cube of model equal to p d to the power 5 and cube of prototype. Now this is pm by dn to the power 5 nm to the power 3 equal to pp by dp to the power 5 and np to the power 3 Now we have to find out PP equal to PM into dP by dm to the power 5 into NP by nm to the power 3 equal to 30 into 10 to the power 5, and dP by dm is 5 to the power 5. This is 5 to the power 5, and NP by nm is 353.5 by 1000 to the power 3. Now this is this power comes 4143 kilowatt. Now we have to calculate ratio. Next, third is ratio of flow rate of two pumps, that is model and prototype. That is Q by dQ and of model equal to Q by dQ and of prototype, that is Qm by dmQ by nm equal to Qp by dP Q and P. Now Qp by Qm equal to dP Q and P by dm Q nm, or this can be written as dP by dm cube into nP by nm. So this is 5 cube into 353.5 by 1000. So this ratio comes 44.1875. So you have to solve the questions asked in the examination. Thank you.